All right, let's talk about leveling up our Python skills. We're going to move beyond writing those simple scripts that, work most of the time and start building professional, truly resilient applications that know how to handle the unexpected. Let's dive in.
So, I'm sure you've been here. You write some code, you run it, you're feeling pretty good about it, and then, bam, the whole thing just stops, and your screen is suddenly filled with this wall of angry red text. It's something every single developer has felt, but it's also something we can absolutely get under control.
This right here is a traceback, and it's basically Python's way of screaming that something went terribly wrong and it had no idea what to do. In this case, it was a zero division error. Now, for a quick little script, this is, annoying, but for a real application that's out in the world, this is a catastrophic failure. The program just hit a brick wall and gave up.
And this is what we're talking about today, what I call the code crash problem. It's all about code that's fragile. Code that works great when everything is perfect, but just shatters the second it runs into something it didn't expect. Our mission is to build something way, way stronger.
Okay, the key to solving this is really a mental shift. We've got to stop thinking of these things as just errors. An exception is an event. It's a signal that something unusual happened. And the best part is, Python gives us the power to intercept or catch that event and decide what to do, instead of just letting the whole thing burn down.
So how do we actually catch these events? Well, our first line of defense is what's called exception handling. And I want you to think of the try except block as the airbag for your code. Yeah, a collision might still happen, but the airbag deploys to prevent total system failure, letting the program continue on in a controlled, safe way.
So how does this airbag work? It starts with the try block. This is where you put the risky code. Anything that you suspect might fail. Maybe it's a network request, a file operation, or in this case, some sketchy math. You wrap it inside a try block. You're basically telling Python, hey, keep an eye on this next part. And this is the airbag deploying. When that risky code inside the try block fails, the program doesn't crash. Instead, Python jumps immediately to the except block. It's our safety net. We've caught the specific error, and we get to run our own code instead, completely avoiding a total shutdown. Now, this system is actually a full-blown toolkit. You've got try and except, which we've seen, but there's also an else block, which is cool because it only runs if there was no error at all. And then you have finally. This one is super important. The code in the finally block will always run, whether there was an error or not. It's perfect for cleanup tasks, like closing a file or a database connection. So this is great, right? Our application doesn't just fall over anymore. It's resilient. But hang on, we have a new problem. The program just quietly handled an error and moved on, and all we got was a little print statement that disappears forever the second the program closes. How on earth are we supposed to figure out what went wrong days or even weeks later?
And this brings us to Level 2, Professional Logging. If exception handling is the airbag, then logging is the black box flight recorder for your application. It's a system that records everything, events, warnings, and especially errors, so you have a permanent detailed record of exactly what happened, when it happened, and why.
This chart really nails the difference. Using printf can kind of like shouting into the wind while you're debugging. It's temporary, it has no context, and it's gone forever once you close the terminal. But the logging module, that's the professional tool. It's persistent, it saves to a file, it adds crucial info like timestamps and severity levels, and it's totally configurable. And logging comes with these built-in severity levels. Think of this like setting the sensitivity on your black box. While you're developing, you might want to see everything, so you set it to debug. But in a live production app, you might only care about warning and above. This lets you cut through the noise and focus on the real problems. And setting this up is actually really straightforward. All you have to do is import the logging library and run this basic configuration. You just tell it what file to write to, what the minimum level of severity is that you care about, and how you want each log message to be formatted. Just like that, you've got a permanent record of your application's life.
So we have the airbag to stop the crash, we have the black box to record what happens, now it's time for the main event, putting them together. This right here, this is the pattern that separates hobby projects from truly professional, resilient software.
And here it is, the pro-level synthesis in action. It's so simple and so powerful. The try block does its thing. When the error happens, the except block catches it, preventing the crash. But instead of just printing a useless message, it calls the logger. The airbag deploys, and it immediately tells the black box to start recording. Now, the real magic is this one specific command, logging.exception.
This isn't just a regular log message. When you use this inside an except block, it's special. It automatically knows an error just happened and it grabs the entire error traceback for you and puts it right into your log file. No extra work needed. And this is the glorious result. This is what you see in your app.log file. Look at all that beautiful information. You've got a timestamp, you know it was an error, you have your own custom message, and, most importantly, you have the full detailed traceback showing you exactly what line of code broke. This is absolutely priceless for debugging a live application.
Whew. All right, we went all the way from crashing code to a really robust system pretty quickly there. So let's just do a quick summary of the key takeaways to make sure this all sinks in.
So here's the pattern. First, exceptions are your airbags. Use try-except to handle errors gracefully so your app doesn't die. Second, logging is your black box. Ditch the temporary print statements and use a real logger. And finally, the pro move is to combine them. You catch an exception, and then you use logging.exception to record it perfectly. Your program stays alive, and you get a perfect record of the error. Best of both worlds.
So I'll leave you with this final thought. Your code will encounter the unexpected. It's not a possibility, it's an absolute guarantee. And when it does, what's it going to do? Is it just going to crash and burn, leaving you totally in the dark? Or is it going to handle that event gracefully and leave you a detailed report that informs you exactly what you need to fix? The choice really is yours.